Hi, today we're going to learn about multiplication of matrices. So in this section, I will find the size of two matrices and determine if two matrices can be multiplied. I will multiply two matrices with the help of an entry number. Also, I will write a matrix equation as a system equation and solve it. So first, I'm going to go over the definition of a matrix multiplication. So the product of an m by n matrix A and an n by p matrix B is an m by p matrix AB, whose entries are found as follows. The entries in the ith row of A by the corresponding entry in the jth column of B and adding the results. So an example would be this matrix 1, 2, 3, 4, we will call this A, right? Call this matrix A, and it's a 2 by 2. And then this other matrix, -2, 5, we'll call that matrix B. So we're going to multiply those two matrices AB. First step is I'm going to determine if it's possible. So we said that matrix A is a 2 by 2 and matrix B is a 2 by 1. So you look at this number 2, this 2 and this other 2. If they're the same, that means it's possible. So yes, it's possible. And then the other numbers we look at is the 2 and the 1. This is going to be our new form matrix, so it's going to be a 2 by 1. So our answer, when you multiply these matrices, you get an 2 by 1 matrix of 8 and 4. And how I got 8 and 4 is I literally multiplied this row by this column. So if I multiply 1 times -2, and then I add 2 times +5, I get 8. And I have to do it with the same with this row. So 3 times -2 plus 4 times 5 is 14. So this should be a 14, sorry. So this is how I got a 14 in a 2 by 1 matrix. Pretty self-explanatory. So it says find the size of AB in each case if the matrices can be multiplied. So on number 9 it says matrix A is a 3 by 4. So matrix A is a 3 by 4, and matrix B is a 3 by 4. First I gotta determine if it's possible. So I look at these two numbers, 4 and 3. Are they the same? No, so it's not possible. So yeah, we can't multiply it because it's not possible. Not possible. So we can't multiply it. So it now says find the following. So we have a matrix 3. We gotta multiply these two matrices, right? First I gotta determine if it's possible. So we'll call this matrix A and we'll call this matrix B. So matrix A is what kind of matrix? It's 1, 2, 2 by 1, right? It's a 2 by 1. And matrix B is this goes by rows and columns, so it's 1 row, so it's 1, and there's 2 columns, 1, 2, so it's a 1 by 2. So these numbers are the same, 1 and 1, so it's possible. Now we have to look at the other number. We have a 2 here. I'm going to box this 2, and then I'm going to box this 2. So our new matrices is going to be a 2 by 2. So now we got to figure out what is our answers. What are our numbers for our 2 by 2 matrix? So we're going to multiply 3 times 5 and then 3. Our second column number would be 3 times 6. and then our second row is going to be 1 times 5, and then our second row is going to be 1 times 6. So it's going to be 3 times 5 is 15, 1 times 5 is 5, 6 times 3 is 18, and then 1 times 6 is 6. So matrix AB is this matrices. So we know it's a 2 by 2, and can you see what it's like we're multiplying this 3 by this whole 5 comma 6, right? This row by this row 3, so I'm multiplying 3 by 5, and then 3 times 6, and then our second row is going to be 1 times 5, and then 1 times 6. Okay. So it says find AB, find AB and BA in each case. So we have a matrix. So first let's find AB. What is matrix A? Matrix A. So it's a 1, 2, 3, 3 by 3, right? And then this is going to be 1, 2, 3, 3 by 1, 2, 3. So these are 3 by 3. So is it possible? We have a 3 here, we have a 3 here, yes. So our new matrices is going to be a 3 by 3. Okay, that's our new matrices. Now we got to find out the numbers. So what I'm doing is I'm literally multiplying this thing by this thing, right? This row by this column, this row by this column. So to make it simpler, I'm going to show you step by step. So my first row, first number is going to be 1 times 1, right? So we're multiplying this row by this column, plus 2 times 0, and then 3 times 0, plus 3 times 0. If you do all the work, you get positive 1. And then we'll multiply this row by this second column. So it's going to be 2 times 1 plus 1 times 1, and then 3 times 0. So this is 2 plus 1, 2 plus 1 is 3, and then 0, so it's just 3. And then this is going to be this row by this column. So it's going to be 3 times 1 plus 2 times 1 plus 1 times 1. So this is going to be 6. So remember, this is going to our new matrix AB. Hold on, let me just move this. So remember our matrix, I have to put it, AB is going to be 1, 3, 6, right? We got that number, and we're going across. And then now we're going to multiply um, 1. Now we're doing this row by this and all 3 columns, right? So I'm going to multiply this row by each and a single column. So this is going to be 2 times 1 plus 1 times 0 plus 3 times 0. So that's 0, 0, that's 2. And then 2 times 1 plus 1 times 1 plus 3 times 0. Right? 2 times 1 is 1 plus 1 times 1 plus 3 times 0, so this is going to be 3. And then 2 times this by the last column, so 2 times 1 plus 1 times 1, and then plus 3 times 1. So this is going to be 6. So this, we're going to go by the row, so it's going to be 2, 3, and 6. And then our last column, our last row is going to be this row times by each column. So it's going to be 3 times 1 plus 2 times 0 plus 1 times 0. That is what? 3? And then this by this column, so it's going to be 3 times 1 plus 2 times 1 plus 1 times 0. That's going to be 5. And then the last one, this row by this column, so it's going to be 3 times 1 plus 2 times 1 plus 1 times 1. And that's going to be 6. So this row is going to be 3, 5, and 6. So that is AB. Now we got to find, so 1, 2, yeah. So we know it's a 3 by 3. And then we also have column numbers. So this is going to be A1, 1, because this goes by row 1, column 1, right? This is going to be A1, row 1, column 2. This is going to be A1, 3, etc. This is going to be A2, 1, A2, 2, A2, 3, and then this is going to be A3, 3, A3, 1, A3, 2, and A3, 3. So if they ask you what is A3, 1, it's 3. What is A3, 2? 5. What is A1, 12 is 3. So that's the column number. Now we got to find BA, right? So BA, I'm just going to write B. So B is, I'm going to rewrite B. So B is 1, 0, 0, 1, 1, 0, 1, 1, 1, and then A is 1, 2, 3, 2, 1, 2, and then 3, 3, 1. So we get we know this is a 3 by 3, this is a 3 by 3, so it's possible, right? Same number. So so BA is going to be a 3 by 3 as well. Okay. Now, just like the same, so we got to multiply this row by this column, this row by this column, this row by this column, right? So this, it's going to be 1 times 1 plus 1 times 2 plus 1 times 3. That equals 6. And then 1 times 2 plus 1 times 1 plus 1 times 2. That equals 5. How I got that? So I'm multiplying this by this column, and then now I'm multiplying this by this second column, and now I'm going to multiply this by the third column. So this is going to be 1 times 3 plus 1 times 3 plus 1 times 1. And that is 7. So our first row is going to be 6, 5, 7. Our second row, so I'm going to multiply this row by each and every single column of A, right? So it's going to be 0 times 1 plus 1 times 2, and then plus 1 times 3, that is 5. And then I'm going to multiply 0 times 2 plus 1 times 1 plus 1 times 2, and that's going to be 3. I'm going to multiply 0 times 3 plus 1 times 3, and then 1 times 1. That equals 4. So it's going to be 5, 3, 4. Right? So what I did was I multiplied this second column by each column of A. Right? And that's how I got 5, 3, 4. And then our third row is going to be this row and multiply it by each column. So it's going to be 0 times 1 plus 0 times 2 plus 1 times 3. That's going to be 7. 0 times 2 plus 0 times 1, and then plus 1 times 2 is going to be 2. This is going to be 0 times 3 plus 0 times 3, plus 1 times 1 equals 1. So this is going to be 3, this should not be 7, this should be a 3. So this is a 3, 2, 1. So it's going to be 3, 2, 1. So do you understand how I got 3, 2, 1? So I multiply this row by each and single column of A. So I did 0 times 1 plus 0 times 2 plus 1 times 3. And then I did 0 times 2 plus 0 times 1 plus 1 times 2, and I get 2. And I'm going to do 0 times 3, which is 0, 0 times 3, and then 1 plus 1, that should give us 1. So BA is this one, 6, 5, 7, 5, 3, 4, and 3, 2, 1, and it's 3 by 3. And like I said, if you wanted to find the cell number, so this is going to be A1, column 1, because it's on the first row, and the first row and first column, that's why we got 6. And this is going to be first row, second column, first row, third column, and this is going to be second row, first column, right? 5 is going to be second row, first column, and etc., right? Right? This is going to be third row, first column, third row, second column, blah, blah, blah. Okay. So, find each product if possible. So, I did not write the... So I'm going to first... Yes, sorry. Sorry about that. I didn't write the problem. So we gotta find. So we have a this product, this matrix 1, 3, 2, 4, 3, 4, multiplied by this matrix, square root of 2, 0, and then square root of 2. So I gotta first determine if it's possible. So we could call this matrix A and we could call this matrix B. So matrix A is what kind of type of, it's just going to be, so it's by row by column, so 1, 2. So that's 2 rows, and then how many columns? 1, 2, 3. What about matrix B? How many rows do we have? 1, 2, 3. How many columns? 1. So if these two numbers are the same, which is 3, which is possible, which they are, so it's definitely possible. But what is our new matrix going to be? It's going to be a 2 by 1. Okay, now let's do the work. So what I'm doing is I'm going to multiply this row by this column. So it's going to be negative 1 times square root of 2 plus 2 times 0 plus 3 times square root of 2. And that's going to give me 2 square root of 2. Now I'm going to multiply this row by this column. So this is going to be 3 times square root of 2 plus 4 times 0 plus 4 times square root of 2. If you add all that up, that's going to give us 7 square root of 2. Now we have to make it in a 2 by 1 matrix. So a 2 by 1 is 2 rows and 1 column. So it's going to, our final answer should look something like this. Right? Because it's a 2 by 1. And these are our answers. So it's going to look something like this. Good. Okay, so write each matrix equation as a system equation. Solve the system by the method of your choice. So what I'm going to do is we could call this matrix A, we could call this X, and we could call this B. If I multiply AX, right, AX, what was that going to give me? So I'm going to multiply this row by this column. So 1 times X is X, and then, wait, before we start, go any further, can we multiply AX? So this is a 3 by 3. This is about 1, 2, this is a 3 by 1. So it's 3, 3, yes. But our answer is going to be a 3 by 1. So I'm going to multiply, first it's possible. So I'm going to multiply this row by this column. So 1 times X is X, plus 1 times Y is Y, plus 1 times Z is Z. And that we should equal this to B. So B is our answer. So that's going to equal 4. And then 0 times X is 0. 1 times y is plus y, right? 1 times y is y. And then 1 times z is z, so it's going to be plus z equals 5, because that's what our b is. And then this row by this column. So 0 times x is 0, x plus 0 times y is 0 times y, plus 1 times z is z, right? And that should equal 6. Let me clean, so if we clean this up, I'll put it right here. It should be x plus y plus z equals 4. This is just a 0. 0 times x is 0, so we're just going to leave that blank. So it's going to be y plus z equals 5. And then this is going to be 0, 0. So this is going to be blank, blank. So I'm just going to let that be z equals 6. So this was really simple. We got to find what's x, y, and z. So all we got to do is plug it into, we can use substitution, right? because this is they give us an answer, z equals 6, so let's figure out what y is. So y plus z, which is 6, equals 5. Subtract 6, so y equals -1. Now let's plug in, let's find what x is. So we know what our x plus y, we know y is, so it's -1. And our z is 6, right? Yeah, z equals 6, equals 4. So 6 minus 1 is 5, so it's x plus 5 equals 4. And then subtract 5, x equals -1. And if you were to plug it back into the original equation, so x is -1, I'm putting it in here, plus y, which is -1, plus z is 6. Does that equal 4? 6 minus 2 is 4. Yes, 4 equals 4. And then y plus z, so -1 plus z is 6. Does that equal 5? 6 minus 1 is 5. Yes. What about this one? 0, 0, 0, 0, and then, yeah, z 6 equals 6, right? So that's true. So we know this is this. Those are our three solutions. So our our x, y, and z is -1, comma, -1, comma, 6. That's our final solution. And what I did was I just first multiplied this ax. First I determine if it's possible, and it's possible, so I can multiply ax, and we set that to b, and then I just use simple substitution. Okay, last one. Write a matrix equation in the form of ax equals b that corresponds to each system of the equations. So this is kind of like the other one we just did. So we can call this, but it's kind of like going backwards in a way, right? Remember our last problem? We got this kind of looks like this. So we kind of have to go backwards. So first let's figure out what our a is. Our a is basically the coefficient of these x, y, and z. So it's going to be 1, 2, -1, right? How I got that, it's just the coefficient of these numbers, 1, 2, -1. This is going to be 3, -1, and +3, and this is going to be 2, 1, and -4. That is our matrix A. Our matrix X is basically the variables, x, y, and z, so we'll just call that x, y, and z. And then our B is basically this column, or the answer, so it's going to be 3, 1, 0. Good. So so it's just saying write a matrix equation of a form ax equals b. It does not say to solve for it. Yeah, we don't have to solve for it. So we have to put it in this form, ax equals b. So we know a is this one, and our x is this one, and then it should equal to b. So it's pretty self-explanatory. So it's going to be 1, 3, 2, 2, -1, +1, -1, 3, -4, and then our matrix x is just this variable, so it's going to be x, y, z equals b, which is this 3, 1, 0. And this is your final answer, this whole thing. So if you like my video, please like and subscribe. Thanks.